A bond that holds two or more atoms together. Chemical bond. A chemical bond is a connection between atoms allowing them to form compounds. Imagine trying to keep a group of friends together at a crowded concert. Just as you might hold hands or link arms to stay connected in the bustling crowd, atoms form bonds to stay together and create molecules. In both situations, a bond acts like the link or connection that prevents separation. For people, it's the physical grasp, and for atoms, it's the chemical bond that holds them together in the vast crowd of the universe. A shorthand that uses symbols to represent elements in a compound. Chemical formula. A chemical formula shows the types and numbers of atoms present in a molecule. Imagine trying to explain a complex recipe to a friend, but you only have a few seconds to do so. This is similar to how scientists use chemical formulas to convey detailed information about compounds quickly and efficiently. Just as the recipe shorthand might list 2 eggs, 1 cup sugar, 1 cup flour to summarize the ingredients, a chemical formula like H2O uses symbols and numbers to represent the elements and their quantities in a compound, allowing for quick understanding and communication. The substance made when atoms from two or more elements combine chemically. Compound. A compound is a substance formed when different types of atoms bond together, like water being made of hydrogen and oxygen. Imagine trying to bake a cake with ingredients from your pantry. Just as flour, sugar, eggs, and butter combine to create something new and delicious when baked together, atoms from different elements combine to form a compound. In both scenarios, individual components, ingredients, or atoms come together to create a new entity with distinct properties, like a cake or a chemical compound, that is different from any of its individual parts. A chemical bond formed when atoms share electrons. Covalent bond. A covalent bond is when two atoms stick together by sharing some of their outer electrons. Imagine two people trying to stay warm on a cold day with only one blanket between them. This situation is similar to a covalent bond, where two atoms share electrons to achieve stability. Just like the two people share the blanket to keep warm, the atoms share electrons to fill their outer energy levels, creating a stable bond between them. The attraction between oppositely charged ions, ionic bond. An ionic bond is a strong connection formed when one atom donates an electron to another atom, resulting in positively and negatively charged ions that stick together. Imagine trying to fit the right puzzle pieces together, where only specific shapes can connect to complete the picture. This is similar to how ionic bonds work, where oppositely charged ions are like puzzle pieces that naturally attract and fit together due to their complementary charges. Just as a puzzle piece with a protruding tab needs a piece with a matching indentation to connect, a positively charged ion, like a sodium ion, is drawn to a negatively charged ion, like a chloride ion, forming a stable ionic bond as they come together to complete the picture. A bond formed when metal atoms share electrons. Metallic bond. A metallic bond is when metal atoms pool their electrons, allowing them to move freely and create a strong, flexible connection. Imagine you're at a crowded concert where everyone is trying to pass around a limited number of glow sticks to keep the party going. Just like the concert goers sharing glow sticks to stay lively, metal atoms share electrons to maintain a stable structure. In this analogy, the concert goers are the metal atoms, the glow sticks are the electrons, and the lively atmosphere represents the strong, cohesive force of a metallic bond that holds everything together. The unequal sharing of electrons in a covalent bond, polar bond. A polar bond is a type of covalent bond where electrons are shared unequally. causing one end to be slightly positive and the other slightly negative. Imagine you're sharing a blanket with someone on a cold night, but your partner keeps hogging most of it. This uneven distribution of the blanket is similar to the unequal sharing of electrons in a polar covalent bond. Just like one person ends up with more of the blanket, in a polar bond, one atom attracts the shared electrons more strongly, creating a partial negative charge, while the other atom becomes partially positive, much like the chilly person left with less blanket. A solid of ions or atoms arranged in an orderly three-dimensional pattern. Crystal. A crystal is a structure where particles are arranged in a repeating, organized pattern. Imagine trying to organize a bookshelf where every book has a specific spot, and you can't just place them randomly. This is similar to how atoms or ions are arranged in a crystal, where each particle has a precise position in a three-dimensional pattern. Just as a well-organized bookshelf allows you to find and access each book easily, the orderly arrangement of particles in a crystal ensures structural stability and predictability in its properties. An ion made of more than one atom, it may have a positive or negative charge. Polyatomic ion. A polyatomic ion is a group of bonded atoms that together have an overall electric charge. Imagine trying to carry a stack of groceries with various items balanced precariously in your arms. Just like these groceries, which are a collection of different items that you must manage together, a polyatomic ion is a group of different atoms bonded together, carrying a collective charge. Just as the groceries might feel heavier or lighter depending on what's in the stack, a polyatomic ion may have a positive or negative charge depending on the balance of electrons among the atoms, all moving as a single unit. An electron in the outermost energy level of an atom, it helps form chemical bonds. Valence electron. Valence electrons are the outermost electrons of an atom that determine how it reacts with other elements. Imagine you're at a party, and you're the person standing near the door, ready to meet new people and make connections. Just like you're positioned to easily interact and form new friendships, valence electrons are positioned in the outermost energy level of an atom, ready to form chemical bonds. In this analogy, you are the valence electron, the party is the atom, and the new people you meet are the atoms or molecules that bond with you, showing how valence electrons are crucial for forming bonds, much like you are crucial for forming social connections at the party. A number written below and to the right of a chemical symbol. Subscript. In science, a subscript indicates the number of atoms of an element in a molecule. Imagine you're trying to bake cookies and need to know how many cups of sugar to use for each batch. Just as the recipe tells you the exact amount of sugar needed for each set of cookies, a subscript in a chemical formula indicates the number of atoms of an element in a molecule. In both cases, the number is crucial. The recipe's measurement ensures the right sweetness, while the subscript ensures the correct composition of the molecule. A model that represents an atom's outside electrons using dots. Electron dot diagram. It is a simple diagram that shows the valence electrons of an atom as dots around the element's symbol. Imagine trying to remember which of your friends are available to hang out by looking at a calendar with dots on it. Just like how each dot on the calendar represents a friend who is free on a particular day, an electron dot diagram uses dots to represent the electrons available for bonding in the outer shell of an atom. In this analogy, the calendar is like the atom, and the dots signify the friends or electrons that can interact, helping you visualize which atoms can bond together, much like figuring out whose schedules align for a gathering.